Hello there, now I am on my editor and here we are going to code for depth first search. We are going to apply the depth first search on a tree that we developed of 4 nodes, and after coding it we are going to verify or check the outputs. So let's begin. So first of all I'll comment that from this section we are trying to develop the depth first search function, DFS, that is depth first search. So the intention here is to first code the function and then actually understand the flow and logics thoroughly. So let's begin. We know that depth first search for tree traversal has 3 subsections, that is PreOrder, InOrder and PostOrder. So first of all I'll make or define a function for PreOrder depth first search, which will take node as an input, and what it will do is first of all it will create an array by the name visited, and then I'll define another function traversal or traverse, and that will take node as input, but since we are using node twice now, that will create confusion and error. So what I want to do is I want to make a quick correction. So for traversing, we are traversing the node, but for the depth first search in the pre-order, we are performing it on the root of the tree. So from that logic, I'll just change the argument name for the depth first search pre-order function from node to root. So root it is, and for now I'll just pass this function. We will look at it later. It's basically going to perform the traverse job, and at the end of this traversal function what I want to do is I want to make the call to this traverse function, and I want to pass the root as an argument, and then after the traversal is done I want to return the visited as our answer. So the traverse function that I have created or defined inside our DFS pre-order function is a very popular method in recursion programming, and it is called a helper function. Now let's program this function. So what we want to do is we want to check if there is a left child, and if there is a left child we want to traverse it, making a recursion call to the traverse function. Then if there is a right child we want to check that, and if there is a right child we want to make a recursion call to the traverse function, that is node.left. node.right. So essentially when this traversal function is being called or is being traversing the tree, we can observe what actually is happening. So what is happening is first of all we traverse to root and we go check if there is a left child, and if there is a left child we again get into that traversal recursion call, and then again we check if there is a left child, and as long as there is a left child we are going to go down the path, and if there is no left child we are going to check if there is a right child to that node, and if there is a right child again we are going to go to that right child and check for left, and if there is a node who doesn't have left, again we will check for right. We are going down the path and as far as we can go, and when we hit the case where there is no left or right child to that node, what happens is the function is over and we get out of the traversal. So we get basically in the stack terms on the next element, and that will be the next previous recursion call, that is we are essentially moving up a node, and then again we are checking for the right or left and so on. So it's a recursion taking place to ensure that we are going to the depth first, and I believe there is no clarity at this point. It could be that it's not crystal clear. You are getting a sense of we are going down the path, but exactly what is happening is not clear. Don't worry, we will look at that on the whiteboard, but for now just stay with me. That's the idea. You get the idea how depth first search traversal is working, right? But we didn't make any update to the visited array. It's still empty. So even though the entire traversal is taking place, we do not have anything to show for. So we have to fill this visited array as we traverse through the tree down the path towards the depth first approach, right? So how do we fill this visited array? In this traversal function, where do I write visited.append node.val? And basically that has the significance of subdividing the depth first search into pre-order, in-order and post-order. So for starters if I were to first of all correct the spelling of traverse. So if I were to add or append the node dot value at the very top of checking left or right child, it will be a pre-order depth first search. Now I'll copy the entire function and paste it down. The only change that I'm going to make is instead of this being the pre-order depth first search, I'm going to now define it for in-order depth first search. And instead of appending the visited list on the top, I'll do it in the between of the left child and right child traversal. So that is why it is in order. And again I'll copy paste the entire function, and instead of making it or calling it an in-order depth first search, I'm going to define it for the post-order depth first search. And the change will be, you guessed it, I'll cut this out and paste it at the bottom of left child and right child traversals. So now let's check the output of the various traversals. First of all, there is breadth first search that we did in our previous videos. Then now I'm going to make the printing call for the three depth first search functions, namely pre-order, in-order and post-order that we just coded. So first of all, I'll print the pre-order depth first search starting with n as the root. Now I will again print, and this time it will be for depth first search in order traversal. And I'm going to make the call to our function DFS in order and pass n as the root for the tree. Now again I'll make a print, and this time I'll do the depth first search post order traversal. And to do this, I will make a call to our function DFS post order, and as the root parameter I'll pass n. Now just for the clarity, I'll print here DFS downwards from here. So now I'll run the program, and this is our tree, the commented section. So this is our tree, and we have the various traversals, corresponding traversals, breadth first search, pre-order traversal, in-order traversal, post-order traversals, and we see that all of them are different. So next up we will shift to our whiteboard and understand the differences, how these outputs were created and how the recursion calls were made, so that we have a clarity and crystal clear understanding of the recursion calls being made, the logics of the function and the flow of the function. So now let's try to understand the pre-order and in-order depth first search traversals. In order to do that, what we are going to do is we are going to apply or execute the pre-order and in-order traversals on this nice little tree of 4 nodes, 1, 2, 3 and 4. The intention here is to understand the recursion calls and the flow of the recursion programming that we did for depth first search, because this recursion flow is very much the heart of the depth first search, especially the way we coded. So I'll begin with the traversal for pre-order depth first search. So the way the entire flow will start with is the root. So what will happen is a call is made to traverse root, and root is 1, so I'm going to pass 1, and the first thing that is going to happen is, let's say the answer for pre-order is visited and it is empty. So the first thing that happens when I make a call to traverse the root is this function, this line will execute it, and the value of the node is appended, and node here is the root, that is 1 with value 1. So 1 is appended, and then if node dot left, so does the node 1, this node, has a left child? Yes, it very much has, and it is the node with value 2. So since the if condition is true, we will actually execute the following set of this command of traversing the node dot left. So what will happen is we will traverse the node with value 2. So for the simplicity's sake, I'm passing the value as the indication of the node that we are traversing. So now I am inside this traverse function. So again I am inside this traverse function. So again I am back to line 1 or this traverse, and this time the node is 2. And when I am again back, I'll execute the first line again, but this time it will be for the node of value 2. So the function asks me to, the command is first to append the node.val to the visited. So again I'll do that, and this time it is the node with value 2. Now again this line will be checked if node.left. So does node with value 2 has a left child? Yes, it very much has one, and it is 4. So again I'll execute the traversal call to node with value 4, and again I will execute the appending operation, which is I will append 4 to our visited list, and then again this condition will be checked. Does node 4, so the node with value 4, has a left child? No, it doesn't has one. So okay, we will skip the traversal call to the node.left because the condition is false. Now if node.right, so does the node with value 4 has a right child? No, it doesn't have one. So what will happen is the function over here is ended, right? The function had only 3 lines and it got over. So this function got over, and we come out of this function back to this one, and in this function we were over here because we had checked the node.left and we had then gone to the traversal of node 4. Now I'm going to check if the node with value 2 has a right child. Well, does this node has one? A right child? No, it doesn't has one. So we will again not execute the traversal call, and again the 3 lines of code are exhausted for this traversal to node 2. So again we are over with this function and we are going to come out of it, and when we come out of it, we find ourselves inside the traversal of node 1. So now we have done the checking of left child for node 1. So does the node with value 1 has a right child? Yes, it has one. So what will happen is we will traverse, so to be in line here it will be traverse node with value 3, and the first line will execute it, that is appending the node value to the visited list. So I will append it. So I have appended it, and this node doesn't have a left child nor a right child, so both of the conditions are false, nothing happens, and we come out of it. And where do we hit when we come out of it? We find ourselves inside this, and inside this we executed the last line as well. So we are over, we come out of this as well, and we are out of the traversal recursions, and we have the visited list ready. The visited list that consists of depth first search traversal of the node values in the pre-order. Now we will again do this for InOrder and see how the output comes. So again it will be a visited. So this entire structure is basically a stack operation disguised in the form of recursion, but that is all there is to this program. That is all there is. So when we actually break down and look at it from very slowly and confidently, we find it is not that hard as it might have looked when we were on the editor and doing it. So let's do the InOrder traversal now. So in the InOrder, what will happen is we traverse the root, that is 1, and then we do not do anything to the visited list, but we check for left child. Does 1 has a left child? Yes, it has one. So we traverse 2. Does node 2 has a left child? Yes, it has one, and that is 4, so we traverse it. Does node 4 has a left child? No, it does not have. So we do not do anything. Then we hit the visited for the first time in the code. And there it is saying that we append node value to our visited list, and we are over here. So we append that. We append 4 to our list. Now we will check if there is a right child to node 4. No, there is no right child to node 4. So we come out of it and we find ourselves inside the traversal function where the argument is for passed as node 2. So we have checked the node left and we are on the second line. So we actually the first thing that we are supposed to do is now is execute the second line, because the first line has already been done, which took us to the node 4. So the second line is to append the node value to the visited list. So I will append that, and we are at 2, so I am appending that. And then I will check if there is a right child to this node. No, it's not there. So we are over with this also, and we come out of it. We are on the root with node value as 1. So we have made the left call and we are over here. So again, I'm going to make the changes to the visited, that is appending the value, and then I'm going to hit this line. If node is right, if node dot right is present, so does node 1 has a right child? Yes, it has one, that is 3. So I'm going to traverse node with value 3. Does that node has a left child? No, it doesn't have one. Then I'm supposed to update the visited array, so I'll append it with the value of 3. And does that have a right child? No, it doesn't have one. So we are done, and we come back to this function. And that when we come back to this function, we find ourselves on the very last line, so we are almost over. So we are over with this function and we come out. And when we have come out of this function, we find that the visited list is ready, which contains the node values of the tree in the order of InOrder traversal for the depth first search traversal. So this is how the InOrder works, and I believe that this example is enough and encouraging enough for you to take pen paper and do the similar verification for the PostOrder traversal, where the visit.append operation will take place after checking if there is a node dot right. So go ahead and take the pen paper and do it for yourself. But with this, we are very crystal clear with how the traversal techniques are working, the exact flow of the recursion calls that are being used for developing the depth first search, and that is it. Thank you very much.